Okay. Hi, my name is Michael Chan, and this is the graduate showcase. I'm here to demonstrate my project of hardware modeling of implementation of a neural network for orientation selectivity of the eye. I know it's quite a mouthful to say. So in my project, I'm just going to demonstrate what my project does on the FPGA. So a little bit about it. It's a neural network inspired model that I did for detecting specific angles. And the angles that I detect are 0, 45, 90, and 135 degrees. So you have to present that angle in this small 20 by 20 pixel box. So when that happens, if you set it to a specific angle, the outputs show out here, but these outputs are only tuned to a specific degree. So for this output, it's 45 degrees for these two 7-segment displays. For these two, it's 135 degrees. For these two, it's 90 degrees, and for these two, it's 0. So their numerical hexadecimal value will be the highest if the stimulus is orientated for that specific degree angle. So I'm going to give a demonstration. So I'm going to show you a stimulus of a horizontal. So what I'll be using for the stimulus is a protractor with a black and white piece of paper for the stimulus. Basically, I'll just use the edge for detecting the image in here. So that's where I'll line up the edge. I'm going to have to come around. Okay, so right now I have the protractor set up to 90 degrees, so it's vertical. So this is what it looks like on the camera. So you can see the white and the black edge are aligned, but you have to align it in the center of the 20 by 20 pixel box for the stimulus. Okay, so on the output on the other side of the FPGA, notice that the highest value that shows is the 90 degree output, meaning the stimulus being shown in that small box is orientated more closely to a 90 degree angle than the other angles. Another degree angle that I could show is, say, 45. So I'm just going to set it. Okay, so that's about 45. And now I'm going to align it inside the box. So the 45 degree angle edge is about centered. So you notice for the leftmost one it's 45 degrees. So that has the highest value comparatively to the others, because this sort of counts the pulses out of the neural network for that oriented angle. Okay, and I'll do something like a small deviation of 45 degrees. Say I'll do 40 degrees, because people ask me this a lot. So then I'll center the stimulus inside the box, and can you get a picture of that? So that's what 40 degrees looks like. I don't know if you can see, but that's okay. You can take my word for that. And then, based on the output, it's a little lower than the maximum. So earlier the maximum was like 60 something, but now it's like 37 or something like that. But remember, these values are in hexadecimal, so they are base 16 numbers. So the more you deviate from the preferred angle, the lower the value usually is. And then the last thing I want to show is the characteristic curves I got. So generally, for say like the 45 degree output, if you show the orientation at 45 degrees, then generally you get the highest output. But generally, if you show it like a small angle deviated from the preferred angle, in this case like 40 degrees or 50 degrees, then you'll get less than the preferred output. And then if you show it way off in the preferred angle, then it just has no output generally, and it just shows like zeros for the output on the FPGA. And that's it for my project, so thank you.